How's it going, folks? Wednesday. Yeah, yeah. How are we all doing? -1, moving on into inverse functions, adding the new layer of one-to-one functions. Hopefully, the idea of inverses was a reminder of what we did in integrated 3. And it's like, oh yeah, I remember those inverse stuff. So, essentially, doing a recap, we talked about an inverse function is you take the domain and range and you switch them. And so we can find the inverse function by essentially switching the x and y value and getting y by itself. So that is a way for us to find an inverse function. There is a special type of function called a one-to-one function. And essentially, a one-to-one function, if this was our graph, a one-to-one function passes something what we call the horizontal line test. So if you draw a horizontal line, it'll only cross the graph once. And essentially, one-to-one just means for every one x, there is only one y value. Or conversely, for every one y, there's only one x. Now we can determine if our functions are one-to-one in two ways. We could use the definition, and the definition says if f of c equals f of d, then c equals d. So we can actually show if a function is one-to-one using that definition there. That is basically how we do it. So starting with number 1, we would say my function with c plugged in equals my function with d plugged in. Now I'm just rewriting it just to kind of emphasize, instead of x, it's going to be c. And then instead of x here, we plugged in d. So we start with that, and what I want to show that c equals d. If you can get c by itself on one side and d by itself on the other side, then we've proven that it's going to be one-to-one. So I could take the cube root to both sides, and so you get 2c plus 3 equals 2d plus 3. Then I can minus 3 on both sides. 2c equals 2d. Divide both sides by 2. And you get c equals d. And so because I have that c equals d, I know that this function is one-to-one. And if it's one-to-one, it automatically has an inverse, or the inverse is also a function. So that actually tells us a bunch of different things with that. Another thing that we can do is we could plug it into Desmos. And give me a second with that. And we could even look at it, and we'll know that it's going to be one-to-one. So 2x plus 3 cubed. So looking at it in Desmos, I can draw an infinite number of horizontal lines, and it's always going to pass that horizontal line test here. Even if I zoom in right here, it looks like it's getting flat, but it's not. It's still increasing until there's an instantaneous part right here where it's 0, but then it continues increasing. So it's one-to-one. I'll leave that there. So any other questions with that? I'm going to do number 3. because number 3 is kind of tricky. And you already know how to do it. It's just kind of like what we do with it is kind of weird. So what ends up happening is if I wanted to show if f of c equals f of d, so f of c equals f of d. Okay, so now I have to show the c equal d, right? So to get rid of that absolute value, it actually becomes plus or minus 7 minus 3c equals plus or minus 7 minus 3d. Because remember, anything inside of the absolute value, you're going to get a positive or a negative. It's like all those different combinations of it. When you have an absolute value or equaling an absolute value, we get either the positive equal a positive or the positive equal a negative, right? So those two scenarios, you'd get 7 minus 3c equals 7 minus 3d. And then the other scenario would be a positive equaling a negative. So remember, because you get plus or minus when you break apart the absolute value. Now, solving for this one here, you can minus 7, you get negative 3c equals negative 3d, and then divide by negative 3. And then on this one, we do get c equals d, which is great. So far, it's proving to us that this is 1-to-1. But now let's look at the other one. Well, with the other one, I have to distribute the negative. Well, somehow, okay, add 7 maybe. Oh, now I have 14. So I get 14 minus 3c equals 3d. Well, if I get d by itself, it's not c equals d. So it's actually impossible on that one to get c equals d. So because it's impossible for me to get c equals d, it's not 1-to-1. Let's look at that in a calculator. The absolute value of 7 minus 3x. So take a look. See, that fails the horizontal line test. If you were to draw a horizontal line, it's going to hit there, and it's going to hit there. So because it's going to fail the horizontal line test, it's not going to be 1-to-1. So any questions on that so far? Okay. Well, cool. So I'm going to let you guys give that one a shot. Oh, that reminds me. Let's look at the one from yesterday. Because remember I said I wanted you guys to kind of work this one out. Did we figure it out? Are there any questions on that number 7 from yesterday? I don't know how many of us gave it a shot. Do we need more time on it? Did we want to try it and I'll check in tomorrow? Okay. So you want to try and go over it and check it? So the order is, so it should be k of j of f of g of h of x. I believe that's right. So if I take, sorry, wait. Yeah, no. So if we start with the x plus 2, which is my h, so I plug in g into that, so that becomes negative x plus 2. I'm sorry, I need to switch those. Whoops. I was right. I wrote it down wrong. There we go. So I take, sorry. So I have this x plus 2, and I'm taking my g, which is negative x, and plugging it in. So I get negative x plus 2. Then I need to take that negative x plus 2, and I need to plug that into my f, which gives me the square root of negative x plus 2. Then I need to take that and plug it into my j, so I get 3 times the square root of negative x plus 2. And then you take that and you plug that into your k, and that's what gives us that minus 4 at the end. Does that make sense, Jocelyn? So you plug the G into H, into F, into J, into K. Yay. All right. So any questions on the complex numbers part? Just remember that like z bar, that means the conjugate. So if z is 3 plus 2i, then z bar would be 3 minus 2i. Any on the adding or multiplying or dividing? So maybe I'll do for number 5, I'll do the w over z just as a reminder. So w negative I over my z. So the way we get rid of the I in the denominator is by multiplying the top and bottom by the conjugate. So if I distribute the top, you get negative I plus I squared over, if you distribute the bottom, you're going to get 1 minus I squared. I squared is negative 1. So that's going to go to negative 1, so you're going to get negative 1 minus I. And then this is negative 1. So 1 minus negative 1 is 2. Now it's proper for us to write it as a plus bi. So then this will get broken into that. And there's my a, and there's my b. So it'll be negative 1 over 2, and then negative I over 2, but there's a 1 in front of that I. It's 1i. So that's why I can write it as this. Negative 1/2 minus 1i. 1/2 I. Okay, well, there's no questions on that. Questions on 7 or 8? Those are just the graphing the rationals. Is there any of those that you would like at least me go over if you don't have questions? So even just looking at these, they both have oblique asymptotes because the degree on top is larger than the bottom. The degree on top is larger than the bottom. So you're just going to have to use polynomial long division to find that oblique asymptote. Number 8? Okay. So for number 8, x squared minus x minus 6 over x plus 1. So my vertical asymptote, well, let's factor it, see if something cancels. Okay, nothing cancels. So then my vertical asymptote, you set the denominator equal to 0 and solve, and so you're going to get x equals -1. There is no horizontal asymptote because the degree on the top is larger than the bottom. So we need to divide. Let's get some light in here. There we go. So we need to divide, and we'll do the division right here. X squared minus x minus 6. And then you get x plus 1. So x goes into x squared x times, multiply, subtract, then you divide. X goes into -2x, -2 times. Now the rest doesn't matter because we don't have to worry about the remainder. So my equation of the asymptote is going to be x minus 2. So x minus 2, up 1 over 1, up 1 over 1. It's hard to draw dashed lines. And then I have a vertical asymptote at x equals -1. So those are my asymptotes, the red. Now I just need to pick values, and you just plug them into your calculator. So values that I would plug in would be on both sides of the vertical asymptote. So values like -2, -3, and -4. And then values like 0, 1, and 2. So you just want to take those, and you're going to want to plug them in. And if you do that, it should look like this. So x squared minus x minus 6 over x plus 1. And I could show the asymptote, so y equals x minus 2, and then x equals -1. So the graph will end up being like on this side and on this side. But you just have to plug those into the calculator and plot the points. And I'm assuming we know how to do that. Okay, what about... So this is kind of like what we've been working on in the past couple days. The composition of functions. So for example, on number 9, let's say if I wanted to do f of g of -1, remember the way that we visualize this is f of g of -1. So I need to take -1 and plug it into my g function. So plugging in -1 into my g function, you're going to get 2 over, and then 7 minus 1, I get 6. So you get 1/3. So that is the g of -1. So then you get f of 1/3. So now I need to plug in 1/3. So I'm going to get 1/3 over 1/3 plus 5. So from there, we can enter that in our calculator and get an approximate. Or we can just do that by hand. So find the common denominator. Plus 15 over 3. So that's going to give us 1/3 over 16 over 3. And that's, the 3 is going to cancel out. So I'm going to get 1 over 16. And that's going to be my answer. I'm going to be right back. There's someone at my doorbell, and I'm going to go answer it. So I'm going to do a little quick little intermission. All right, I am back. So I have to wrap it up here in a few minutes. But sorry that it's the roofing guy is here 15-20 minutes early. So said actually 30 minutes early. He said he'll be here at 11:30 and he showed up at 11. So yeah. So there's that's basically how I find that. Are there any questions? Are there any of these other ones that you need to be, want to look at before we go? Okay. Well, if there are no other questions, then I think I'm good. Good luck with your roof. Thanks, Jocelyn. Finally, someone's coming out to fix it. I'm so excited. So I appreciate it. If you have any questions, Jocelyn, just let me know in Discord. Other than that, thank you very much, guys, and have a good one.